Hello students, in this video we're going to learn new operations. The first one is the union, the second is the intersection, and the third is the difference operations. These are set theoretic operations, means that they work on sets. For example, the union operation is written like this: R1 union R2. You should notice that the union, intersection, and difference operations are binary operations. This means that they are applied to two relations at a time. In contrast with the select and the project and the rename operations that are unary operations, they are applied on only one relation at a time. However, union, intersection, and difference are binary operations because they apply to two relations at the same time. For example, the union, this is the union operation, R1, for example, union R2. We have the set difference operation, R1 minus R2, and also we have the intersection operation, R1 intersection R2. There are conditions when using the union, intersection, and the difference operations to apply any of these operators to relations. These relations should be union compatible. What does this means? That the two relations must be union compatible. So two relations are with the following attributes: A1, A2, AN, and another relation S with the following attributes: B1, B2, BM are said to be union compatible. We call that these two relations are union compatible if they have the same degree. This means that n equals to m. This means that the first relation must have attributes, must have the same number of attributes as the second relation S. Okay, here n represents the number of attributes in relation R, and here m represents the number of attributes in the relation S. So the first condition, in order for these two relations to be union compatible, they must have the same degree, which means that n equals to m. So the same number of attributes must be the same in these two relations. The second condition for these two relations to be union compatible, the domain of AI should be equals to the domain for the column BI for all I between 1 and n. This means that the domain of the first column from the relation R should be the same domain as the first column in the domain in the relation S. This means that if A1 is an integer, then B1 should be an integer. If A1 is a character, then B1 should be a character. Also, this applies or should apply to all columns in for the first relation and all columns in the second relation. So we have two conditions for two relations to be union compatible. First, they must have the same degree or the same number of attributes, and each attribute must have the same domain for the corresponding attribute in the second relation. So this means that both R and S have the same number of attributes and the corresponding attributes have the same domain. Okay, let's start with the first relation called the union relation. Operations called the union operation. So this is the symbol of the union operation, the letter or the symbol U. The format of writing the union operation is R1 union R2. This means the relation R1 is united with the relation R2. What does this what will this returns for you? It will returns all tuples that belong to either R1 or R2. So we have two relations R1 and R2. Each relation has for example several rows or several tuples. Then there may be common rows or common tuples between these two relations and uncommon rows. R1 union R2 will returns all tuples that belong to either R1 or R2. So it will returns all the tuples or all rows that are found in R1 and in R2. So how can I write it in terms of set? R1 union R2 will return for me a set. This set or the elements of this sets are the tuples T, such that this tuple T must belong to the R1 or this tuple T must belong to the relation R2. So it will return all tuples that are belong to the first relation or to the second relation. Okay, here we have a condition of union. In order to use the union operation, R1 and R2 must be union compatible, as we have said in the previous slide. Here they must be union compatible, means that they must have the same degree or the same number of attributes and the same domain for corresponding attributes. The union operator removes duplicate tuples automatically. So if there is a duplicate row between the first relation and the second relation, this row will be removed by using the union operator. So the union operator is similar to the project operation because they remove the duplicate tuples automatically. Let's take an example here. If we have this relation R1 with 3 rows, the first row, second row, and third row, and relation R1 has columns A, B, and C. Also we have another relation R2 with the columns A, B, and C, and with the row 1, row 2, row 3, 4 rows, with 4 rows, and R1 with 3 rows. And I want to compute R1 union R2. First of all, in order to compute R1 union R2, R1 and R2 must be union compatible. And this is true because the degree of R1 is the same as the degree of R2, because the number of columns in R1 is 3, because we have 3 columns A, B, and C, and this is the same as in R2, A, B, and C. Also, R1 and R2, also the domain of each column is the same. For example, here we have column A, and here we have another column A. So they are having the same domain. Here are the values A1, A2, A3, and here the values are also A. And this applies also for the column B and for the column C. So they have each column have the same domain as the corresponding one in the second relation. Now we can apply the union operation. The union operation will return for us all rows that are found in R1 in addition to all rows that are found in R2, but if we have duplicate elements, then these duplicate rows will be removed. Let's first go to the relation R1. Then this row will be in the result A1, B1, C1. This is the first row. A2, B2, C2 will be in the result. A3, B3, C3 will be in the result. Then we finish R1. Next we will go to the relation R2. A0, B0, C0 will be in the result because A0, B0, C0 is not found here. Then it is listed the first time, then it will be in the result. A1, B1, C1 will not be listed here because it's already found in A1, B in relation R1. So and it's written in the result here A1, B1, C1. So it's written only one time because the union operation removes the duplicate. So this is a duplicate row. And we have another duplicate row A2, B2, C2 because it's found here A2, B2, C2. Then this will be removed. It will not be written here. And the last row here A4, B4, C4 will be written because we don't have here A4, B4, C4. Okay, in the next video we are going to learn about the set difference, so stay tuned.